Okay, second semester, we're going to start with Chapter 5. Chapter 5 is going to deal with linear inequalities. We'll be solving them, we'll be graphing them. Just like everything we did with equations, we're going to do it with inequalities in this chapter. So 5-1 is solving inequalities by using addition and subtraction. Right? We've done with equations, we've done addition and subtraction. Now with inequalities, we're going to learn how to do addition and we're going to learn how to do subtraction. Now we've done this a little bit before, so this should feel fairly familiar to you. We'll have two vocabulary words, inequality and set builder notation. All right, inequality is an open sentence that contains less than, greater than, less than or equal to, or greater than or equal to. The addition property of inequalities is just like the addition property of equations. If you add the same number to each side of an inequality, you're going to get another statement that's also true. So just like we could add the same number to each side of an equation, we got another statement that's true. So for instance, if you have A is greater than B and you add C to both sides, you're going to get another inequality that is true. Okay, let's look at an example. We have x minus 12 is greater than or equal to 8. Okay. Well, we're going to add 12. We're using the addition property of inequalities. We're going to add 12 to both sides, and we find out that x is greater than or equal to 20. We can check our solution. If we want to check our solution, we will substitute 20 in for x. So 20 minus 12, is that less than or equal to 8? Is 8, greater than or equal to 8? Is 8 greater than or equal to 8? Yes, it is. So the solution set for this is all numbers greater than or equal to 8. The solution set here is all numbers greater than or equal to 8. So if 21 would work, any numbers greater than 20. Okay. A more concise way to write a solution set is to use a set builder notation. So your definition for set builder notation is a concise way of writing a solution set for an inequality. All right, so for that example we just had, example 1, here is what a set builder notation would look like. It would be, oops, sorry. It would be the set where we would say the set of all numbers x such that x is greater than or equal to 20. All right? And that can obviously be graphed as well. And you'll remember when you're graphing it on a number line, we've graphed inequalities before. If it's equal to, you're going to have a solid dot on your number line. If it's just greater than, you're going to have an open dot on your number line. But in this case, it's greater than, or x is greater than or equal to it. So it's all these numbers above 20. And that's how you'll graph it. Make sure you remember that you're supposed to have arrows on each end. And you don't have to start at 0 on your number line, but you do have to have a couple of numbers on either side on your number line to let us indicate which way you're headed with it. Okay, by the same token, we can solve inequalities by subtraction. Again, like the subtraction property for equations, the subtraction property for inequalities states that if you subtract the same number from each side of an inequality, the resulting inequality is also true. So if we have A is greater than B and we subtract C from both sides, we're going to get another inequality that's true. All right, here's an example for us. All right, m plus 19 is greater than 56. So I'm going to subtract 19 from both sides, and I have m is greater than 37. right? So if I was going to, do we have to graph that on a number line? It didn't say to. But on the number line, let's go ahead and do it just for practice, right? Here's 37, here's 38, here's 36, okay? It's greater than, so it's an open circle, it isn't equal to it, and m is greater than 37, so it'll be everything in this direction. Okay, here's some guided practice. Here's a only one practice problem for you right here. And it's a multiple choice question, so you have to figure out which one of these is true. Go ahead and do that problem and then start the video back up when you're done. All right. Sometimes there are variables on both sides. As in this example, 3a plus 6 is less than or equal to 4a. So we're going to solve that inequality, and then we're going to graph the solution set on a number line. All right. So simply what we'll do is we'll say 3a plus 6 is less than or equal to 4a. Of course, that's the first thing we do is write down our problem. Now, we're going to have to get the variables all on one side and the whole numbers all on the other. So I'm going to subtract 3a from both sides. So 6 is less than or equal to a. So that was easy enough. We just have to get variables both on the same side, just like we do in an equation. Be careful that you leave something on each side of the inequality sign, just like with equations. Now, although we didn't do it here, and I'm not going to do it here, do remember, though, that as a general rule, it is a good idea to keep the variable on the left side of the inequality, because then it's easier for you to write it in set builder notation. We'll come across that again later, but that's just something I wanted to make a note of for you, and we'll talk about it again later. Okay, here are two practice problems for you. If you want to go ahead and do those, pause the video and start it back up when you're done. All right. Here's a chart. You guys have written this chart before, but I just wanted to throw it up there for you again in case it helps you to remember. These are some phrases that indicate inequalities. For less than, it might say less than, it might say fewer than. Greater than, there's another, you can also say more than. Less than or equal to means at most, no more than, or less than or equal to. It may say any of those phrases in a word problem. If it's no more than a number, it could be that number, but it couldn't be more than that number, so it has to be less than that number. So no more than is this symbol right here. And here we go with greater than or equal to at least, no less than, or greater than or equal to. So look for those key phrases in your word problems. All right, here we have a word problem. Philippe needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees. Currently, the basking spot is 62.5 degrees Fahrenheit. How much warmer does this basking spot need to be? It needs, remember, it needs to be, here's the phrase, at least 82 degrees Fahrenheit. So it has to be greater than 82 degrees, but it could also equal 82 degrees, couldn't it? So T is the number of degrees that the temperature needs to rise. That's how much it has to increase. This is what it is currently, 62.5. So 62.5 plus some number T is greater than or equal to 82. So that's how we set up our problem. And then you would solve for that problem, right? 62.5 plus T is greater than or equal to 82. And we'd subtract 62.5 from both sides. That would leave, subtract that from both sides. That leaves us T alone over here, greater than or equal to, and we get 19.5. So how much does it have to rise? It has to be at least 19.5 degrees warmer. If I make it 19.5 degrees, it'll be right at 82. If he gets any warmer than that, that's fine. It just needs to be at least 82 degrees. Okay, here's a practice problem for you. Do it and then start the video back up. And that is your last problem for the day. We'll go over these tomorrow in class. If you have any questions, we'll talk about this lesson and we'll do some practice problems. So I'll see you next class.